Sustainable development and climate action. Higher education creates academic hubs for students and researchers to develop practical solutions and gain hands-on experience through interdisciplinary collaboration to tackle complex challenges. They also provide opportunities for mutual learning and experimenting with new technologies, testing new approaches, and conducting innovative research that inform evidence-based policies and practices, allowing governments and communities to participate.
11 Maret University, as one of the outstanding universities in Indonesia, is transforming towards the vision of a Golden Indonesia 2045 and becoming a world-class university through its organizational character entitled Dream Team. The Faculty of Engineering, as part of Universitas 11 Maret or UNS, aims towards more significant contributions in facilitating graduates and researchers to achieve more sustainable as well as climate resilient visions.
The Faculty of Engineering Universitas 11 Maret is located in Surakarta, or well known as Solo, a very comfortable city to live in where culture and modernity meet. Solo is located in central Java, which is only 80 kilometers from Borobudur, one of the World Heritage Sites protected by UNESCO. It takes 55 minutes from Jakarta by plane and about an hour flight from Bali. The Faculty of Engineering Universitas 11 Maret was founded in 1976 at the same time as Universitas 11 Maret. Its embryo stemmed from a combination of 8 universities which merged into the Universitas Gabungan Surakarta or UGS, which in 1980 began providing education with 2 study programs, namely Civil Engineering and Architecture. The Faculty of Engineering has continued to grow rapidly over the years, positioning itself to become a leading engineering education institution in Indonesia. The Faculty of Engineering has committed to providing high-quality education. Here, students can choose study programs and carry out research and community service based in the field of integrated and sustainable engineering to solve climate resilient problems. Students can pursue career paths from undergraduate to doctoral programs. All study programs in the Faculty of Engineering have been accredited by both national and international accreditation institutions. Led by lecturers who are dedicated and have high integrity, the Faculty of Engineering offers a unique and engaging learning environment, providing an inquiry learning process where students are required to contribute actively both in the classroom and in the field. In order to accelerate the clean energy transitions, the Faculty of Engineering has a Center of Excellence for Lithium Battery Science and Technology, which focuses on research into the development of lithium batteries and advanced energy storage technology to support electric vehicles and renewable energy. CEVs does not only a teaching factory, but also produces product innovations in energy storage technology up to the downstream stage teach how the product can arrive and provide benefits to society.
Welcome to the Integrity Zone of the Faculty of Engineering at Universitas 11 Maret. The Faculty of Engineering offers both academic and professional education tracks. The Faculty of Engineering is committed to strengthen governance to be more adaptive and synergistic. Our spirit is Teknik Satu, Teknik Maju, synthesizing unity to enhance achievements. The Faculty of Engineering at Universitas 11 Maret invites prospective undergraduate, master's and doctoral students along with potential collaborators from academia and industry to join us in building a global network.
The Faculty of Engineering has collaborated with universities from all over the world in both education and research. International partnerships such as student exchanges, summer programs, joint degrees with various institutions abroad are one of the efforts to provide a learning environment with a global perspective in order to answer global challenges while remaining based on the noble values of national culture. Students can improve their soft skills through various student activities and organizations on campus, supported by adequate learning facilities, a clean and comfortable environment and easy access to online information systems make students more independent and achieves more achievements both at the national and international levels, makes them ready for tomorrow's challenges. The Faculty of Engineering, Universitas 11 Maret.
International Conference on Industrial Electronics, Robotics and Informatics, ICIERI 2024, is organized by Faculty of Engineering, 11 Maret University, and joint collaboration with Venus University, Gadjah Mada University, National Research and Innovation Agency, Republic of Indonesia, TU Delft, National University of Singapore, University of Ulsan, Ho Chi Minh City University of Technology and Education, Bristol University, and Numidia. The theme of ICIERI 2024 is Embracing the Future Through Green Technology Innovation. This event will include participation of renowned keynote speakers. This is our speaker. The committee accepted 83 papers after reviewing 115 papers from various countries including South Korea, Singapore, Malaysia, Thailand, India, Peru, Nigeria, and Indonesia. Accepted papers will be presented in person or virtually and published in reputable proceedings series, SPIE proceedings.
Namo Buddhaya.
Good morning, ladies and gentlemen. Welcome to the first International Conference on Industrial, Electrical, Robotics and Informatics, or ICIERI 2024. Embracing the future through green technology innovation. It is a great honor for me, Aditya, and my partner,
Bilva.
for standing here and welcome all of you to this wonderful event.
To begin our spectacular event, let us take a moment to express our gratitude to Allah Subhanahu wa Ta'ala for granting us health and happiness. May peace and blessings be upon our Prophet Muhammad Sallallahu Alaihi Wasallam, who has guided us to this path of life.
Thank you to all our distinguished guests.
Honorable guests, we would like to acknowledge and extend a warm welcome to our distinguished guests. The Honorable Chairman of ICIERI 2024, Mr. Joko Haryono PhD, the Honorable 11 Maret University Dean of Engineering Faculty, represented by the Head of Department Electrical Engineering, Insinyur Sutrisno PhD, the Honorable Multimedia University of Malaysia, Fahmid Al-Farid PhD, the Honorable Head of National Research and Innovation Agency, Dr. Engineering Teguh Mutaki,
The Honorable Head of Research Organization of Electronics and Informatics National Research and Innovation Agency, Dr. Engineering Budi Prawara, the Honorable Binus University Head of Doctor Department, Professor Fort Lumban Gaul, the Honorable Lead Computer Vision and Deep Learning Lead Engineer, Code Atlas of Russia, Mr. Alexander Filonenko PhD, the Honorable Co-Founder and CTO of Indonesia 17, Mr. Andi Setyo Nugroho, and to all audiences that joining our event today. Thank you for attending this prestigious event.
Ladies and gentlemen, before we get into the session, please allow me first to read the agenda for today. First, we start with opening ceremony. Next, we will be singing the national anthem Indonesia Raya. Next, there will be speech by the chairman of ICIERI 2024 and followed by speech from Head of Department of Electrical Engineering Insinyur Sutrisno PhD. For the next, there will be photo session followed by coffee break.
The fifth agenda is speech from our keynote speaker, 11 Maret University Dean of Engineering Faculty, Professor Dr. Insinyur Wahyudi Sutopo STMT. It will be followed by a series of invited speeches and plenary session. Lunch break will be done after that. The next main event, parallel session 1. And then a coffee break will be held before parallel session 2. And then parallel session 2. As the closing or last agenda, there will be award announcement and closing.
Ladies and gentlemen, let us start our event by reciting Bismillahirrahmanirrahim together. Bismillahirrahmanirrahim.
Honorable audiences, for our national anthem Indonesia Raya, to the all audiences, please standing up.
sit down for all audiences.
Before going any further, let's pay attention to the speeches welcoming remarks from the chairman of ICIERI 2024, Mr. Joko Haryono, PhD. To Mr. Joko Haryono, PhD, the stage is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. On behalf of organizing committee, it is my pleasure to welcome you in the first conference, international conference on industrial electronics, robotics, and informatics. As we know, ICIERI 2024 is organized by Faculty of Engineering, Universitas 11 Maret, which collaborate with some institutions. First is Binus University, Gajah Mada University, National Research and Innovation Agency, Republic of Indonesia, TU Delft, Singapore, National University of Singapore, and University of Ulsan as our partner, and also Ho Chi Minh City University of Technology and Education, and the last is Numedia. And for this conference, the theme is about embracing the future through green technology innovation. This conference also held as hybrid conference, which come at in person or virtually. For the in person or venue for this conference, we located in Surakarta, especially in the Alana Hotel and Convention Center. We want to report about this conference. The committee accept 83 papers after reviewing 115 papers from various countries, including South Korea, Singapore, Malaysia, Thailand, India, Peru, Nigeria, and Indonesia. Accepted papers will be presented in hybrid. However, only about 6 papers will be presented as on-site. The other ones presented as online. We also want to thanks to especially for the keynote speakers who come from Indonesia and also from far away from here, from Russia and also from Malaysia. And also we also thanks to participants, sponsors and partners for their contribution and all committees for their great effort to organize this conference. I wish you a successful and enlightening conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Mr. Joko Haryono for insightful speech. Next, we have a speech remark from Dean of Faculty Engineering, represented by Head of Department of Electrical Engineering, Mr. Insinyur Sutrisno, PhD. To Mr. Insinyur Sutrisno, PhD, the stage is yours.
Bismillah. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Pak Andi from Indonesia 77, Pak Dr. Budi from BRIN, my colleagues, Pak Joko and all the participants of this conference. My name is Sutresno. I'm the head of the Department of Electrical Engineering. I have been asked by my dean, Professor Wahyudi Sutopo, to represent him in delivering the opening speech for this conference. He apologized, could not join this conference because currently he is overseas in Philippines. There is important agenda that he should join the agenda in Philippines. Okay, here I will read the opening remark from the dean. Assalamualaikum warahmatullahi wabarakatuh. The Honorable invited speaker, Professor Fort Luban Kaul from Pinus University. Bapak Fahmi Alfared, PhD from Multimedia University, Malaysia. Bapak Dr. Budi Prawara from National Research and Innovation Agency, BRIN Indonesia. Mr. Alexander Filonenko, PhD from Cloud Atlas Russia. The Honorable, the head of the study program at Faculty of Engineering, invited speaker, participants and colleges. It is a great pleasure and honor for me as the Dean of Faculty of Engineering to deliver this welcome remark at the first International Conference on Industrial Electronics, Robotics and Informatics, ICIERI 2024. Thank you for joining this conference. This conference are organized by Faculty of Engineering, UNS, and in joint collaboration with PINUS, with UKM, and with BRIN, and etc. The theme of this ICIERI 2024 is Embracing the Future Through Green Technology Innovation. This conference will gather professionals from various research institutions, universities, industries, government, and students to share, discuss, and present current advantages in the green technology innovation and promote the Sustainable Development Goal, or SDGs, in the respective areas or field. On the other hand, this conference aims to strengthen international and multidisciplinary research through the multi-collaboration of research, academia, industries, and government. As supported by the committee accepted around 83 papers after reviewing around 115 papers from various countries, including South Korea, Singapore, Malaysia, Thailand, India, Peru, Nigeria, and Indonesia. Accepted paper will be presented in this conference by person or virtually and published in reputable proceeding series or SPI proceeding. Ladies and gentlemen, especially from participants and colleges, global networking and understanding global culture are the important issues to consider by engineers in solving a real case problem. I hope this event, ICIERI 2024, will trigger collaboration among the researchers who participate in this event. International engagement, cooperation are very important in solving the global problem that we are facing. Faculty of Engineering, through around 19 program study, including electrical engineering, undergraduate, master program, and doctoral program, will happy to assist all participants to realize an international networking and to establish building interdisciplinary collaboration to achieve sustainable development goal for the better future. The Honorable keynote speaker, invited speaker, participants, and colleges. On the behalf of the Dean of Faculty Engineering, let me invite all of you to say Bismillah together. Say Bismillah together to officially open this conference. Bismillahirrahmanirrahim. Okay. Finally, success is a part of a progress. As a reward from moving forward, It is time for Indonesia, for UNS, to go global, to be global. Thank you. Terima kasih. Matur nuwun. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Sutrisno, PhD, for your insightful remarks.
Now, let's move to the photo session. To the invited guests, please join us to the front of the stage for the photo session. Please. For the committee, please guiding the invited guests. Okay, are the cameras ready? Okay, give your best smile, please. 3, 2, 1. Okay, once again, give your best smile, please. 3, 2, 1. For the last. 3, 2, 1. Okay.
Thank you for your participation. To the invited guests, you may return. Okay.
Okay, for the
Okay, sorry.
freestyle photo session. All right, thank you for your participation. To the invited guests, you may return to your seat. After the photo session, we will begin our first panel session. For the next session is coffee breaks. Please, to all audiences, enjoy the coffee. To the committee, please guiding the invited guests.
Foto-foto beren, langsung.
Okay, thank you for enjoying the coffee breaks. After the coffee breaks, we will begin a speech remark from Dean of Faculty Engineering, 11 Maret University, Mr. Professor Wahyudi Sutopo. The stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. We distinguished colleagues and participants of the International Conference on Industrial Electronics, Robotics and Informatics 2024. Greetings to all esteemed colleagues and guests attending ICIERI 2024. Though I cannot be with you in person due to an overseas assignment to Aptunet Forum in the Philippines, I am honored to join you virtually as we explore pathways toward a sustainable future through green technology innovation. Today, I am excited to present on the topic embracing the future through green technology innovation. Climate change challenges us all with an unprecedented urgency to transform our energy practices. Today, I will explore how advanced green technologies, particularly energy storage solutions, can address this challenge. We will uncover the potential for such technologies, especially in the transportation sector, where electric motor swappable battery and electric vehicle present incredible opportunities to lead this change. Together, let's embrace this future by fostering collaborative research and accelerating the commercialization of our innovations. Thank you for allowing me to share this journey with you today. Let me begin with the video highlights the critical role of sustainable development goals, particularly the pursuit of affordable and clean energy.
Everybody is going to be affected by climate change. There is no single person in this country or the world who won't be touched or affected. Human activities are the main driver of climate change, mainly due to the burning of fossil fuel such as coal, oil, and gas. This result is not only create a greenhouse effect but also contribute greatly to air pollution. What we're really trying to do is quantify how likely it is people will be affected, what the consequences are, and resilience is about managing the risks and exploiting the opportunities. So, what might be interesting in terms of resilience is knowing what those impacts are going to be and what adaptation we have to take to save the future generations. Following the issue in August 2015, 193 countries through the United Nations agreed on 17 Sustainable Development Goals, which aim to achieve decent lives for all on a healthy planet by 2030. These 17 SDGs is aligned with Indonesia's priorities for long-term growth or RPJMN. One of them is the policy of reducing CO2 pollution through engineering innovation. The Indonesian government is serious about developing battery-based electric motorized vehicles or BEV in the country and has designed a roadmap for the use of electric vehicles as a national means of transportation in the midst of society. The BEV technology innovation will provide transportation solutions that are environmentally friendly, energy efficient, and lower operating and maintenance costs.
From the video, we can highlight our focus to explore how green technology innovations able to contribute to reduce carbon emissions and enhance energy efficiency. The following is an overview of our roadmap research for solving SDGs problems through engineering innovation.
On the other hand, Riset Grup Rekayasa Industri dan Tekno-Ekonomi, Riset Grup RITE or Group Research of Industrial Engineering and Techno-Economics is a group research from the Industrial Engineering Study Program, the Faculty of Engineering which actively focuses on the study of industrial engineering and techno-economics in the innovation technology of energy storage and electric vehicle application. This innovation is an effort to study the field of industrial engineering, especially supply chain engineering, which is integrated with a multi-interdisciplinary approach into the technology commercialization process. Each product of technological innovation has its own unstable and evolutionary supply chain. Innovation in supply chain engineering in the early stages is necessary so that each entity and process involved has operational efficiency and service effectiveness. The innovation contributions that have been generated are in the form of models, methods, and system designs as intervention options to increase the productivity and efficiency of the commercialization of innovation technology. In most cases, many technology products resulting from research happen to fail to be launched to the market due to the valley of death. The obstacle of reducing CO2 pollution using innovation technology usually occurs in the transition process between technology development and technology commercialization. Hence, critical action is needed to accelerate the technology commercialization to ensure the commercialization potency of research output does not fall into the valley of death. The problems of adoption or diffusion of the commercialization of innovation technology about electric vehicle or electric motor and its ecosystem in the Asian market provide an exciting research gap to be solved in joint research with researchers in Asian countries. The study of industrial engineering sciences through an interdisciplinary approach will continue to be carried out to gain contribution to new knowledge on early supply chain engineering integration into the technology commercialization process and to improve the productivity and efficiency of the commercialization of innovation technology. Riset Grup RITE has made a roadmap through various approaches framed within a strategic framework for technology commercialization. Riset Grup RITE carries out various interventions to support the commercialization of technological innovations, particularly energy storage technologies in electric vehicle applications.
For this event, we would like to explore the potential of electric motorcycles in supporting the region's energy transition with a particular focus on Indonesia.
Okay, we would like to continue with our explanation. From the video, we already know about the importance of sustainable development goals, and then also our common enemy to go to net zero emission pathways for the ASEAN power sectors. And the big question, will electric motor cycle overtake two well gasoline powered in South Asia? a big problem. This is the picture of electric motorcycle in ASEAN market, Indonesia, and then also in Vietnam, Thailand, as well as in Malaysia. In most countries of ASEAN, the market of electric motorcycle is growing slowly due to the various adoption diffusion problem. So the objective of the study needs to expand to the ASEAN market problem, enhancing collaboration to solve the problem. This is the illustration, the problem, how the obstacle reducing CO2 pollution using innovation technology. From this picture, we already state that it's very big a problem about adoption diffusion. In the states of technology commercialization, this is the big problem. If we are not cannot solve the chasm of problem, how to crossing the chasm, go to a product itself until to the market. This is the ecosystem of electric motorcycle with challenges of the product, process, innovation, and businesses. In this picture, we also will give us strength point about the importance of early supply chain, including technopreneurs and startup from manufacturer, supplier, and distributors for the commercialization. But the bigger problem, how to crossing chasm that can deliver the product that appropriate with the customer, so the technology itself can adopt by the user. Early supply chain, as I mentioned in the video, we using to develop a competitive advantage and also to develop an efficient supply chain and services effectiveness. Ladies and gentlemen, this is the picture how we should intervene not only in the point of product, but also process, innovation, and businesses. And as a research group of Industrial Engineering and Techno-Economy, Faculty of Engineering, UNS, we already developed early supply chain integration with interdisciplinary approach to the technology commercialization process. We develop a roadmap to maybe step-by-step contribute to solve the problem. And this is the illustration about the complexity of problem adoption from the point of customer perspective and also product perspective, can as a boundary crossing the chasm in the market. This is the illustration. We have one project to investigate customer purchase intention and also how to cross the chasm using a product customer adoption model to find a three-fine solution for electric motor. Based on the project research, we already reveal the chasm problem at the early adopter stage. We already find the factor that impacted to purchasing intention for electric motor in Indonesia context, and we also many suggestion already produced the suggestion manufacturer and government to make more efficient planning and policy by considering the factor including purchasing intention. Based on this research that already conducted by our PhD student, we have the intention method using the product customer adoption model to find a thriving solution for electric motor segment. Ladies and gentlemen, this is also the picture from lesson from Indonesia. What is the driving factors of electric motors adoption? There are two main factors. First is collaboration between the government and electric motor manufacturers, including the provision of subsidies and facilities for the manufacturers. And then the second one is about the increasingly meeting customer preference. Step by step, the products that deliver in the market increasingly meeting customer preference. In the other hand, government also support by subsidies and facilities to the manufacturers. This is the factor driving adoption more easy or more visible. But in the other side, there are still two big problems about embedding adoption. There are bad technology and charging infrastructures. The customer may be still worry about battery, and it's make there are adopt among the public in buying electric motorcycle. Also, the availability of charging infrastructure. Still worry, they cannot replace the energy, the battery, in the station of the charging infrastructure. So, this is the dilemma in the developing of business strategy. Is it important to improve battery capacity first or enhancing charging infrastructure first? Or both? Of course, if the both of the policy is very big investment, so we already conduct an equivalent annual cost model, how to get win-win solution about the problem. This is the methodology to begin with electric motor switchable model, charging infrastructure model, cost model, and cost calculation to get cost comparison to determine the win-win solution and giving the recommendation. And then the second one, we also from the model give alternative of a recommendation how to enhance battery technology, affiliate charging infrastructure investment, and also get competitive pricing strategy. I think it is clear preference for dual battery aims to elevate range efficiency rather than relying solely on the availability of a charging station. Ladies and gentlemen, in the other hand, we also already produced a model to estimating the market share of AM. It's very difficult to say that electric motor will overtake IEC motor in the short time. We already developed the system dynamic model to explore effect of government policy mix on electric motor diffusion. Electric motor sales and market share are also estimated using a system dynamics. We formulate a life cycle cost model that consider social and environmental costs. The simulation as a result show that the estimated electric motor sales are close to the government target, but prediction until 2030 maybe only still about 0.5%.
In summary, the transition to green technology is imperative for combating climate change, and the electrification of motorcycles presents a vital opportunity for sustainable mobility in Southeast Asia. We promote an early supply chain integration with interdisciplinary approaches to the technology commercialization processes. The shift from IC technology to electric motor technology represents a substitution technology to achieve the net zero emission in transportation sector. A multi-platform approach may hinder the ability of electric motors to overtake IC in Southeast Asia. Furthermore, we invite collaboration to innovative solutions aimed to reaching net zero emission using green technology. Once again, I regret not being there with you all, but I look forward to the valuable insights that will emerge from this conference. Thank you for your attention, and I hope you find this presentation both informative and thought-provoking. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Professor Wahyudi Sutopo for the amazing speech. Now let's move to our first panel session that will be featured by two keynote speakers, Professor Ford Lumbangal and Mr. Fahmid Al-Farid, PhD. The chair of the session is Mr. Joko Haryono. To Mr. Joko Haryono, the stage is yours.
Thank you, Master of Ceremony. Okay, we will have two speakers in the first planner talks. I want to sure they are joining. They have joined. The first is Professor Ford, and the second is Dr. Fahmid Al-Farid.
Yeah.
Okay.
Good afternoon, Pak Dr. Joko.
Good afternoon, Professor Ford. Thank you for joining this conference. Actually, you are still jet lag from US, right?
Yeah, it's kind of difficult anyway to distinguish between evening or afternoon.
Yeah. Okay. Thank you, Professor Ford. You will have time for a speech, but I will give some introduction. And the second, Dr. Fahmid Al-Farid. He was already joined. Assalamualaikum, brother.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you. Okay, we have complete two speakers. Actually, first plan, Dr. Ford will come. However, unfortunately, he just arrived from United States and jet lag, and then he joined Zoom. Okay, first I will introduce our speakers. Professor Ford Lumbangal. He is my mate. Currently, now he is head of Dr. Computer Science in Binus University. He have so many organization experience, and as I know, maybe you can show his CV, the slide screen, and I know him as served in IEEE Computer Society before, and he has many experience in organized conference and also as a keynote speaker. And the second is Dr. Fahmid Al-Farid. Dr. Fahmid now in Multimedia University, Malaysia. He obtained a master from University of Ulsan and doctor degree from Multimedia University. Now he working at Multimedia University, and about a field of expert, Dr. Ford, I think he is very expert in computer science, especially in big data and relational. Maybe he will explain about this field. And the second, Brother Fahmid, Dr. Fahmid, also experienced in computer science, especially for the last about computer vision. So I think two speakers will share about his knowledge, and we want to hear from them. Only 20 minutes, Professor Ford for talk, and Dr. Fahmid, and then we have question and answer. So first, Dr. Ford, it's time for you.
Okay. Thank you so much, Pak Dr. Joko. Ladies and gentlemen, please allow me to share my screen. Can you look at my screen?
Yes, good.
Okay. Is it moving, changing the slide?
Yes, changing.
Okay, thank you so much. Ladies and gentlemen, please allow me to deliver my talk today with the title Leveraging Artificial Intelligence in the Law and the Court. This is kind of combinations between the implementation of AI in the law and the court. This is one of probably the domain area that's not quite touched in the area of artificial intelligence. So that's why today I want to deliver some of aspects that will probably become an important one from now in the future. My name is Paul Bangals. I'm a professor and head department of Doctor Computer Science, Venus University. I'm also chair of IEEE Computer Society University Chapters, president of IIA ASEAN region, starting from 2022 until now, and executive director of IIA Indonesia office. I'm also research fellow at the LCIS in Advanced Institute of Industrial Technology, Tokyo Metropolitan Public University Corporate, Japan. I'm also advisory board of Srida University in India, and I'm also the visiting professor in Sam Houston University, Texas, United States, starting from 2022 until 2026. So this is the organization where I belong. This is the agenda that I want to deliver: artificial intelligence in the legal arena, and how AI and machine learning can speed up court cases, and some of the case in the artificial intelligence in the legal arena and artificial intelligence in the courts, and the last, the conclusion. It is about me. This is the organization where I belong. And then this is the book that I have, some of the books, another books that you can find it in Amazon. If you want to buy, this will be fantastic. And this is my Scopus. Now is I have a 409 with index 16. And this is my position in ASEAN regions. I'm also fellow of Alliance for AI and Humanity. This is an organization that's located in Singapore. We are focused on how the AI provide implication and imply into the humanity. This is our campus, Venus University, where I belongs. We are in QS is ranking global 951, and Times Higher Education we are in 1201. In Indonesia we are number 2, and in QS Indonesia we are number 10. And this is our programs this year, Doctor of Computer Science, established in 2014, and we are quite vary in the term of students, 41% from industry and 59 from academics with the student numbers. Bodies is 157 PhD students with alumni 93. Now, ladies and gentlemen, one of the challengings for the AI, especially in the legals, is this. Number one, there are so many information that's supposed to be required when decide or take an action for one decision. It means this is related with technical expertise to be analyzed. The second one, in the term of the legals, the legal activity not only linked to the local jurisdiction. I give an example. For instance, there are so many legal actions is taking cross boundary of countries. And of course, if you look at it carefully about e-commerce, there are so many situations where happens in many kind of cross boundaries, in many kind of cases with the cross boundaries. It means this involve for more than one jurisdiction. And of course, this is related in the legal address issue requested from another's area of expertise. For instance, ladies and gentlemen, there is kind of a legal kind of lawsuit, especially for instance in healthcare. It means we have to explore understanding about the technical issue in healthcare. In other words, for instance, like the issue related, for instance, like in the banking, for instance, it means we have to knowing about the contents in the bank. So here we call it knowledge from another areas. Yeah, something like that. And of course, the most important, efficiency and results. I want to show you for more than 1 million, yeah, 41 million cases we call kind of pending every month. It means it's a serious matter because not only about decision itself, because there are so many cases supposed to be wait and see, cannot be decided. Yeah, this become clear response for regulation and legally trained persons, speedier course decision and reduction of costs. Currently, IT solution based on AI and analytic and machine learning are used in legal activity. For instance, like software to analyze and review contracts. If you ever look at it, the contract they send it to you, there are some of the AI that checking about the content of the contract itself. Drafting and management contracts and e-discovery, tools to discover data in electronic format, and predictive software to predict the outcome of the court decision. This is the last that we want to discuss. Is it possible to implement this kind of situation? Now, ladies and gentlemen, this is the first part I want to say to you how AI and machine learning can speed up court cases. If you look at carefully, the technologies such as AI and machine learning become common across industries, including the legal system. There are 40 million pending cases in private scale court around the globe. Imagine 40 million around the globe. It means this is not only just numbers, but this is a very serious because implication, it means there are so many case situations supposed to be hold because of these cases, pending cases. The use of such technology is critical if the backlog ever is to be cleared. It means we have to speed up, but supposed to be on the target. It means AI and ML can be useful in legal cases. Now, ladies and gentlemen, one of the important here is about how AI can help judge to understand petition. Petition is a formal request a court, in the term of requested for court order, that's we call a petition. AI can help to identify the selling point in court petition. It means judges can able to look at what kind of petition is supposed to be executed in here. You can use natural language processing to look at about original petition itself. On the other side, judges can use AI to search similar cases and of course to take verdicts from a database cases. Now this has become very important because remember, when cases come, there are so many variety of cases. And this can help litigants and lawyers to better prepare for their cases, something like here. And of course, AI can able to identify pre-false case as well. In the AI tools can be used to identify per case at the start. It means certain preset criteria, predicting using machine learning models, and a combination of both, something like this. New case file, AI-based fact checking, and previous case identifier. There are some of now is currently we collaborate in our programs, doctorate program, with friends from the law department about working with some of the real cases, concrete cases that is using some of what we call previous cases in here. Such cases can be squashed at the start to saving the available time of the court. It means it doesn't have to be go to the court, but we can solve it before go to the court in here. Now, ladies and gentlemen, this become important as well to help judges with decision making. Machine learning model can be trained on data set on the past legal cases. It means the judges can not only explore more and more, but also saving the time because judges can be explored for data set per past legal. The trained model can be used to predict the verdicts in ongoing cases based on the similarity with the past cases. This can help the judges to make more correct decisions. If you look at carefully on the right side in here, ongoing case documents plus trained machine learning, and then this we call a predict verdict. So this we call trained machine learning models. In some types of minor cases, AI can be used to pronounce verdicts in the case that are filled online on the basis of the petition documents. It means this can save effort, time, and of course, money for all parties. It means you don't have to come to the court. That means it's totally saving a lot of money in this case. Now, ladies and gentlemen, I would like to share to you about some cases of artificial intelligence in the legal arena. Number one, this we call AI robot in China that can predict decision and avoid cases before the courts. This is one of the example in China. The AI robot in Shanghai, Jiangsu are capable of following possible litigation for a party before the case is filed. So this is become analyzing. This become psychology based on analyzing over 7,000 Chinese law and the numerous court decisions taken in its time. Now this has become important as well. Yeah, because rather than you go to the court, you can check whether this is feasible or not before go to the court. Second, AI in China to detect crimes before they happen. Yeah, Mengzu for Maher Legal, they mentioned about Chinese government will start to use machine learning and data modeling to predict where the crime and disorder may occur. This is one of example. And the third one, this is United States to detect in advance if someone will commit crimes again after punishment. This is one example. Yeah, and in the US, algorithm help recommend criminal sentences in some states in here. This is in United States. And the fourth one, this is in France. Now, this is quite unique because in the France, banning just analytic is become serious matter in here because we cannot be using some of the analytic based on the AI. Yeah, because judge is supposed to be given free to decide, to explore, and to analyze, and after that to decide. Now, in UK, worried about AI algorithm using criminal justice because create national register algorithm in the criminal justice system. That possibility will be save some of the record data set that were used in the training. It means there is a possibility someone will learn from the training and can explore the possibility he or she, if they're using the same kind of situation, goes to the sentences. For example, like this, if someone have the AI here and then they want to know if I'm doing this, if I want doing this kind of criminal, what happens if I go this criminal? And then she can learn it, look at the possibility to avoid the sentence. This is the kind of learning. So in here, this is we call the two sides of the AI itself. That's why UK worry about algorithm used in criminal justice. Now, ladies and gentlemen, I would like to share to you about artificial intelligence in the courts. If you look at carefully, let's say here, in the courts, there is, we call it par is title, judgment, notarial, and then after that, settlement and judgment. Each of part, this is the process here. Title, notarial, settlement, judgment. If you look at carefully here, in the first, we call title, it's supposed to be provide in detail or structured information. There's structures. And then after that, notarial, meaning you have to provide with the support solution explorer. And of course, in the third one, solution explorer, it's maybe a prediction. And the last one, help with research analytics. So this is the situation in the court. Yeah. Someone filed the litigation, and then after that, they have to provide the report. And after that, it goes into the settlement. And after that, to the judgment. Judgment in this case take a decision. So here we call it predictive justice. It means unpredictable court cases outcome at risk. It means someone can make a prediction about what happened if this kind of cases go to the court. So this is the most important principle in the law. Past judgments are correct. That's why all of the judgment previously that's correct, that's become learning. Yeah, like what we have in machine learning. This will be learned to take a decision with the current or the next one. Secure data, correct data, and train algorithm. This is very important. Secure data, correct data, and train algorithm. So all of these one become interact each other and then will be predict. We call it as a predictive justice. According to the European Convention on Human Rights, this is kind of sources from the below. They mention it to 79% accuracy. Wow, this is fantastic. Almost 80%. Because it means predictive. If someone take a court and then there is a 79% prediction accuracy will be correct. Complexity reduction done in process and claim 79 on average. If you asking to me, is it good 79% or not? It's simple. Yeah, it's simple because if you say 79% is good or not, of course, if you look at the numbers, this is quite big. However, there is another issue in here that's probably infected by stimulus of the fact could be additional kind of issue that will be influence the judge will change about the decision. Now, possible AI for solution explorer use chatbot technology for recognition of phone completions. For instance, you don't have to come. You can using the voice recognition and content translation and possible outcome itself. This is kind of ethical charter. They use the AI justices in their environment, respect fundamental right, non-discrimination, quality and security, transparency, and under human control. So this is the European Ethical Charter about use AI in jurisdiction. It's supposed to be respect fundamental right. It means whatever the technology, they're supposed to be goes to the human itself. Second, non-discrimination. This is quite difficult. I want to show you to later on. And the second is quality and security. Of course, this is important. And then number one, transparency. It means you're supposed to be fair, impartiality, and the last one, under human control. So AI will not take control about the justice itself. One example, non-discrimination like this. Yeah. AI sometimes the color of skin can take a decision is wrongly. Yeah, for instance, like this, the left one and the right side. If you go to the eye, could be the right side is supposed to be higher, it's supposed to be the left one is higher, something like that. So that's why here we call it bias to adjust by law. The issue is about bias, bad of the algorithm, lack of data. If you're asking to me, sir, why this has happened? Could be bias of judges or bias of law, bias program, lack of data, bad algorithm. Could be the data itself. Yeah, this we call it unfair treatment. This thing we call unfair, and so on. This is become important as well about non-discrimination. Transparency is in current many countries called. For instance, like in Netherlands, this became important one. Yeah, full timely approach disclosures and to assess choice and to ensure effective legal protection. Transparency became important. It means there is no hidden kind of program, hidden kind of situation that will be influenced kind of the judge itself. Now, this is the other one challenge for court AI and the controls, prescriptive approach, ensure informed actors and user are in control of their choices. It means this is still under human control. Yeah, this is becoming very important. Now, one of the important one, the last one that I want to share to you, the possibility AI can looking about the judge profile. Now, this is becoming very important. If you're asking to me, AI can provide the profiling of people, of course. Yeah, that's why. But the next question is whether the AI can make a judge profiling or not. The answer is, of course, AI can do. It's become important. So, but on the other side, there is some question that's supposed to be do, what for, by whom, and other. Because if you can answer this one, it means judges can be not like human anymore. It's like a machine. They look at on the left and right, on the right and wrong without looking another kind of a side of in the legal itself. That's it. Thank you for me. This is the conclusion. Algorithmic outcome prediction can be useful for legal researchers, but have no place in the court. It means they can using it, but no place in the court. And then algorithmic experts may have a place in the court, especially by making predictions. And the most important is the quality assurance and explanatory. That's it from me. Thank you so much. I give it back to Dr. Joko. Thank you.
If you have any question or confirm something, we will keep after talk from Dr. Fahmid Al-Farid. Okay, Dr. Fahmid. Okay, now time is yours.
Okay, Dr. Zoko, can you hear me?
Yeah, clear.
Okay.
You can see and your sound is clear.
Yeah, let me try to share the screen. Okay. Okay. Can you see my screen?
Yes.
Is it moving?
Okay. Moving. Good.
Okay. Thank you very much, everyone. A very good morning and assalamu alaikum wa rahmatullahi wa barakatuh. So this is Dr. Fahmid Al Farid from Multimedia University, Malaysia. And I'm so happy that and honored my friend, Dr. Zuko. We are like friends since 2013 in University of Ulsan. And we had great memories there. So anyway, I did my bachelor in my home country from computer science and engineering. In the university name is University of Chittagong. So this is the third biggest public university in Bangladesh. So after that, I was working as a engineer in a USA-based company in my capital city, Dhaka. After that, I got the scholarship in University of Ulsan for my MS engineering. So I did my MS engineering in computer science and electrical engineering, focusing on signal processing. And then also I worked in the University of Samsung. It's called SKKU. In Korea, they call it Sangkin Kandehakyu. So I work as a research assistant there for 1 year. After that, I moved to Malaysia. So as a teaching assistant and full scholarship for PhD. So yeah, soon after my PhD, I have joined as a research professor in Faculty of Engineering here. And apart from this, I am a co-founder and director of a IT company here in Malaysia. So, and also we do some research, industry-based research. And we do have a patent on AI and power generation. And I also become a director of a organization that is a charity organization. Name is WW Global Malaysia. So that is the headquarter in USA and New York. We are working with with United Nations in parallel. So I got a short notice actually. So even though I'm really missing the conference physically, if I could get more time, so I'll be very happy later on to come physically if in the next conferences. And okay, so now currently we're working on multidisciplinary fields. Like we do have research grants. So we are working on human action recognition. So we are working on smart farming, which is the topic today. Advancement in deep learning for crop disease detection, hybrid model, data augmentation, and multimodal approaches. So here in this presentation, actually, I'll be focusing on tomato leaf disease detection, one of our research work, but we did research on wet leaf disease detection, paddy field leaf disease detection. So, and eventually this project, we have that goal. We have 3 teams working separately, and we have a goal to have a solution for the smart farming, and which I will explain detail later on, if time allows. So that's all about the introduction. So the abstract. So introducing the ADCLR, a novel technique for precise crop leaf disease detection, leveraging advanced deep learning methods. It overcomes existing limitations, utilizing attention-based dilated CNN, bilateral filtering, also segmentation, and SIGAN for data refinement and achieving the 100% accuracy in training and testing with a remarkable 96.6% validation accuracy on the plant, village database, and so on. And also, so as I said, I will just, because we have a short time, I'll try to focus on the tomato leaf disease detection that we have our in our team, PhD student and also some undergraduate student work together. So, okay, so this is the introduction. So, image processing, feature extraction, classification, and validation. So we can see from here the input image. This is the input image. Here the tomato leaf disease, but we also did on the, as I said, red leaf disease. And we propose different algorithms actually for different leaves disease detection. So pre-processing, and then the synthetic image preparation using GAN. So yeah, okay. So then, so this is the process you can see. Let's go further. So the related study here, machine learning methods. We just mentioned some of the methods that we have used, deep learning methods, and the deep learning with machine learning. Okay. So the material and the method. So, and the type of tomato leaf disease. So here we in the leaf disease class we have bacterial spot, early bright, target spot, yellow leaf curl virus, mosaic virus, lead blight, leaf mold, spectorial leaf spot, two spotted spider mite, healthy and took. Okay, so see the amount of the images and the percentage. So yeah, these are the pictures. Okay, for the sample images of tomato leaf disease. So data processing. In the pre-processing phase, each image received a level based on its file name prefix. The process detailed in algorithm began with the bilateral filtering and also segmentation. So this is the algorithm that I did. So you can see the input dataset of tomato leaf disease. The result pre-processing of tomato leaf disease image data with number of images n. So we did the iteration from 0 to n. So the research, we decide the dimension 256 into 256. Then we process the and resize to 240, 224 into 24 window. And then if normalize the pixel 01. So like this, it continues. So and then we perform the image filtering with bilateral filter, and finally generation of the pre-processed image of tomato leaf. So after that, so the image segmentation. So image, the basic of image filtering and image segmentation. So the bilateral image filtering method is used in this method. So then most texture noise and the small details are removed, but broad sharp edges are preserved. So a Gaussian distribution could be used to calculate the weight. And image segmentation, the segmentation process of an image is a technique that involves dividing an image into regions or segments based on some criteria, such as color, intensity, texture, shape, etc. So the goal is to simplify the image and make it easier to analyze and understand. So this is the process for the synthetic image generation. So we can, from the figure, I believe it's clear enough to understand noise. So okay. So this method uses the Gaussian model to generate synthetic image from pre-processed image. It consists of two neural networks that compete with each other in a zero-sum mechanism. So image generation using GAN, where one network creates images and the other network classifies them as real or fake. Okay. So yeah, this is the tomato leaf is data. So the pre-processing, and you can see how it progress for the scientific image generation. So the proposed hybrid classification model involved this ADCLR, dilated CNN, vector routing algorithm, logistic regression classifier. Okay. So for other leaf diseases, so we propose all different algorithms actually. So the general algorithm of our ADCLR algorithm. Okay. So the input data set of tomato leaf disease. So and then the output is the prediction of tomato leaf disease images. Okay. So the initialization we do with the n is the number and you see the class, and for each iteration 0 to n you see. So we did the process as we mentioned earlier. Then we do the iteration. So then we pre-process after the pre-processed image, sequence-based generation of synthetic image of tomato leaf with the disease level C as you remember, C for the class level. So, and then the initialization of the parameter and then extracted the feature by dilated CNN, and then extracted relevant feature by the attention mechanism. So, and it's continuous. So, and then finally we evaluate all the prediction of tomato leaf diseases images. So, yeah. So the dilated CNN layer for the feature extraction. So you can see the input features from the synthetic images. So here x1, x2, and then xn minus 1. So it goes up like see the dilated convolution until the dilated convolution end. So the attention mechanism also the input is a C convolution from here and then the attention mechanism. So and let's go further to the feature extraction algorithm of DSR model. So we can see here the input synthetic image tomato disease with class level and the result extract feature of FI from tomato leaf disease data pre-processed images J to analyze. So yeah, I think time won't allow us to detail. So if you have more questions later, we can discuss, and yeah, we can also email. So this is the overall process of our proposed method, the input data, then the image pre-processing that we discussed earlier, the synthesis, we already explained the algorithm. After that, the data partitioning, and then the dilated CNN, see the activation. This is the dilated CNN, and then the attention mechanism, feature extraction, classification, logistic regression, and then the result analysis, prediction, and classification result. Okay, so, and this is the main classification algorithm of ADCLR model using logistic regression. These are our proposed model. Okay, so I want to go detail for this. Okay, so, and this is the overall operational process diagram, overall operational diagram of our ADCLR model. Okay, so you can see the input synthesis image here. Okay, so, and then the classification. So this is a very detailed process. It's difficult as we have very limited time. So, and then the evaluation metrics we use as we most of us we know, I think the accuracy, precision, recall, and the F1 score. So, and then the experimental setup. So, yeah, so and you can see the network parameter of the proposed model. Okay, so I think the image is not very big, difficult to understand. So sorry for that. You could put in the maybe different slides would be better. So the experimental, so we use the 80% for the training set, and we use the 20% for the test set, the data. So 1,000 images used for this testing actually. Then we use the Python programming and Google Colab framework and the computer with Intel 3.6 gigahertz, and we do have even 64 GB RAM and the Windows 10. Okay, so the qualitative analysis. So the result analysis, you can see here our model is the attention-based dilated CNN, ADCLR model. And this is the LR model and CNN LR. So our proposed model actually achieved 100% accuracy. So so in the training performance, in the validation also the same. So the LR model, they achieved the accuracy 96.6%, and then CNR LR achieved the 97%, but we achieved 100%. And also in the testing performance, we have achieved 96.60%. So this is the training, validation, and testing performance in ADCL. That's the comparison and the tabular form and in the graph. Okay, so and then so this is the confusion matrix, the area under the curve, and the receiving operating curve ROC. So you can see our condition-based CNN model. This is our model, which outperforms the state-of-the-art model. So the comparison with the state-of-the-art models, this is our ADCLR model. So you can see we compared with the CNN, the AlexNet, the AggregationNet, and the MLPN, LSTM, and so on. So the accuracy we achieved for accuracy, precision, recall, and F1 score, we all got 100%. So the discussion, attention-based feature extraction, real-time test result on new images, and the complexity analysis. So this is the graph to show the comparison. Okay, and then the limitation. So we did a limited scope, and as I said, so we're doing for other liver diseases also and separately, and we're trying to compare, and also we're trying to come up with a algorithm that can actually solve some common problems, but it is a lab-based experiment. So then we do research in the lab, but when it goes for the industry, of course, there are some factors that the constraint that we have to consider. So, and normally in academic research, simulation, we can get the very higher percentage. But when we go for actually, in real life, in field, that the percentage actually reduced. So what we experienced we work in Korea, the research we did there is mostly the research projects we worked. It's attached with the industry, and time to time the research, the professors and the teams were actually evaluating that our work is how it is, comparable with the real, real life world or outside industry. So for us in our project also, actually we are working in a way that maybe in long term we working for that, so that we can really, our product can work actually outside, and we can commercialize it, and yeah. So we have a plan to patent. So I'll also explain on the future work. So in this talk, we introduced the ADCLR hybrid model for liver disease detection, and aimed to improve the accuracy and efficiency in diagnosis, and approach the involved image pre-processing, the synthetic data generation with SIGAN, and the model validation that performed established method is 1,000 images, but it should be done even more with more images. So the currently focusing on many types of diseases, as I mentioned before. So, and to expand it to more broader plant disease detection scenario. So, and the future plan that we now focusing also on the drone-based video surveillance systems for plant disease detection, and also for the patent, as I said. So the objective for this actually develop a real-time disease detection system using drones, and use the advanced deep learning models to classify plant diseases accurately, and improve the efficiency in agricultural monitoring and management. So we just preliminary, we did this flow. We just outlined this flow that we will work like set the path of the drone, and then start the camera to capture the video of the plant, and detect the plant video, and the video contain the plants. Then we proceed. If not, then we just go back to the video processing, and then apply the 3D CNN to extract temporal features. But just we of course will try other algorithms as well. They recognized the disease name and that's the end. So yeah, this is just a picture to understand that we get it from the internet. So from the drone will collect the data, and we want to do it dynamically. So we just divided into 3 years plan. I think I will just finish in a few minutes. So the plan for 3 years that we wanna go for the commercialization and then patenting. So this is the timing diagram for the proposed system. So yeah, as I mentioned in the flow, that's what we just put here. That's all for today's presentation. And this is the reference. And thank you everyone, and thank you for the conference organizers and the committee members to allow me. And yeah, even though it was a short notice, so I believe, and later we'll get more time to prepare and share our ideas and experience. And thank you everyone.
Thank you very much, Dr. Fahmid Al-Farid. His practices implementation using AI. Okay, we have finished for 2 talks. First is from Professor Ford about AI in legal arena, and the second is Dr. Fahmid Al-Farid, especially for the disease detection in the leaf. So now we open the discussion because we are working in hybrid. So first we please the participant in offline. I mean, any question? One. Okay, one. Give the mic. Okay. Time it yours.
Hello, my name is Andy. I'm from industry, not from academic. I have a question for Prof. Ford. He mentioned in the presentation that about the predictive law decision using AI. But in the last slide, he mentioned that it's no place in the justice law right now, I think. But I believe we really need the AI and the knowledge to be put into the system to help us to speed up the decision making on law judgment, yeah. Because as we know, just recently that we have corruption and etc. in MR, and those kind of technology, I think we need to implement in not just in justice or in law, but also in all of the industry to do. Even on my set on IT, I use AI to help us to develop faster and faster. Thank you.
Thank you, Andy. Dr. Ford, Professor Ford, are you in your seat? Okay. Okay, first question for you, Professor Ford. I try to briefly read. In your mention, we are concerned about law and how justice law to cover the AI. Yeah. And actually in Indonesia, this is far from the reality. Yeah. Maybe, how we can implement AI and put in application or system. However, we still in the area of legal.
Yeah, thank you so much, Pak Dr. Joko. Jadi, so when we discuss about legal or court, we're not involved with regulation, no. But we try to use AI as a part of the tools to help lawyer, judges, and to provide better kind of understanding of people when they have provide kind of petition to the court using some of technology AI, especially in NLP and machine learning, something like that. So, like I mentioned in my presentation, that there are so many tools in AI and the machine learning NLP that can be used in the court in the law itself. One example, for instance, like if you are a lawyer and then you want to know what is the previous kind of cases with the verdicts that happens with the same competition, so you can explore it, you can learn it. It's very easily, and you have to know that in the when you look at it about regulation, there are more than probably hundred of thousand kind of regulation that happens, and all of them can interchange each other. So this is a very difficult if you learn it manually and explore it manually. That's why you require tools using the AI itself to help you to provide some of understanding and learning about those kind of previous cases. That's my answers, Dr. Joe.
Bandi?
Do we have the system already online, Pak, somewhere?
Okay, actually, if you look at it carefully, there are some of, especially in the Supreme Court, there's now when you filing the problem kind of a petition actually there is kind of a tools that provide like we call kind of checking whether some of the evidence, some of the what we call a kind of the evidence or kind of petition that you submitted is already in the correct format, something like that. Now that's they're using the AI itself. However, this is kind of a very beginning. Meaning, if you want to asking me whether this can be extended further or not, yes, of course. For instance, you submit the petition and you want to know whether this is will be predicted will be accepted or not, or what kind of the what we call decision of the judge. That's I mentioned to you before that we call it predictive judges. This we can extend it further. But in the current now is when you submit it, there is kind of formatted checking and look at it kind of checking the formality, template and evidence whether that's okay or not, and then mapping it, classifying these cases is belong to this, and so on. So that's kind of initial anyway for the current one.
Okay, already answered. Okay, move to the second question. Maybe we give the opportunity for participant in online. Any question from online? Or can you open the chat? This is question or not? Not yet? Participant from virtual? No question?
Okay, Dr. Zuko. So I have a question to Prof. Pod about just about this. It's a very interesting topic. I'm so happy to see this, Prof. Thanks. So this is a very interesting thing that what do you think in future, like, and most of the courts in all over the world, they will be using AI. I mean, as you said, USA already they're using, and there are some risks also there. So they should have, I mean, resolutions to use, right? So that, I mean, they can, I mean, so that people can get the benefits as well as it really cannot make the problems. So what do you think? Is it developed already? And how about in US, it's use case or in other countries?
Okay. Okay, Dr. Ford, Professor Ford.
Thank you so much, Dr. Fahmid. So this is a very good question. In our research, especially with our PhD students, we already have one of two kind of PhD students already explore integration of AI into the regulation, or kind of we call exploring about finding using the NLP approaches with those kind of cases. So if you're asking to me, how about in the future? Is it possible in the future the AI will be implemented, integrated in the court and judges? The answer is, of course, that's the possible, very possible. Why? Because judges want to know, learn about some of previous kind of cases and verdicts, and judges in this case can also take kind of advantage to to provide more efficient time for them. Efficient in the term of they don't have to spend a lot of time learning with so many kind of predicts and so many cases before. That's the first. Second, especially for the community or the society, this become important as well. They have to knowing about some kind of regulation, for instance. For instance, like Indonesia, if you want to know about some of regulation, then you have the keyword, for instance, certain keyword, and then you wants to know what is the relation between these cases and others. Now, that's one advantage as well, especially for the society. On the other side, this becomes still open kind of research for many, not only for the computer science, but also to the those that have a background about law. It means they can expand about the possibility to collaborate as well when they make kind of research collaboration in this area. Thank you.
Okay, very interesting, Professor Ford. I also have some question maybe for both speakers. First, for Dr. Fahmid, you have already done for disease detection, especially in smart farming, right, brother?
Yeah.
My question is, in the future, you will implement in real time and using drone as the taking picture, right?
Exactly.
This is my question. Actually, if we want to working in real time, it's have speed very fast, right? But in using drone, you cannot take picture nearly. It means you for camera have high resolution, right?
Mhm.
So how you can deal with these situations? I mean, online and also high resolution camera, and maybe you have some treatment for that.
Okay. Thank you, Dr. Joko, for the question. It's a very nice question. So the thing is, for us, the plan we do, now we are doing like static, but in dynamic and static, both will work together. So, and it's very possible actually, if you have a very high definition camera, high definition computer, and the processing can be done. But nowadays, because the technology is very good now, so we believe that the time we will be implementing, even it will be even more better. We can. So it's actually, yeah, it has. We need good funding for this because it's not easy, but we believe it is possible. So and one good thing, I'll be joining as a junior professor in Germany, hopefully next month in Berlin. So I believe in for this kind of actually project, need bigger funding in Europe and US. They have actually, but in Malaysia, yeah, of course they are doing good, but I need actually, the latest technology you have to use, like the tools to annotate the images in the video. So so I believe if we continue the project and collaboration with Asia and other countries, we have a big plan. Let's see how it works. So if we are successful, then we can propose a product that can actually, do the dynamic and static in parallel. And also later on, we want to do some prediction, based from AI that, so how, what will be the, about the bug and the paste. So so that the production increase like that. So it's still not very mature, but we believe we can do that. Thank you.
Okay, thank you very much, Dr. Fahmid. And for Professor Ford, actually, in my university, as in Korea, we have done about face recognition. However, the implementations now moving to the how recognize some mimics or something from face. This is the movement research. And I also working on how we can use face recognition in legal area, for example, judgment or something. In as we have read and learned, we can use face recognition to compare with from, for example, interviewer and interviewee to know this is a lie or not. Synchrony, this is a psychological knowledge. Synchrony, how synchron the first and the second person, so we know he is liar or not. Is it possible using AI to implement that? This is my question.
Okay, thank you so much, Pak Dr. Joko. So there are three issues that we have to be aware in the area of using the face recognitions. The first is about we call data privacy. Data privacy meaning we cannot just took certain kind of data without any kind of permission from anyone as the data set itself. So we have to be careful about that. Second is we have also checked about the possibility, especially with the regulation as well, because in Indonesia the rules, especially for the using the tools to make sure those people whether he's doing the criminal or not is still based on depend with the decision of the human itself, or in this case with the judge. So we cannot using the technology itself as kind of the what we call kind of the aid that become the main kind of tools to decide whether the person wrong or not, something like that. And the third, this has become very important because this required a lot of kind of training. Why I say like that? Because there are some of the situation of cases that possibly the precision can be very low, something like that. So this has become another issue whether we can go through using the technology like that into the court. However, in the past there are some of technology they're still using it. They're already using it and proven. For instance, like lie detectors, for instance, that using in the court in certain kind of cases to check whether the person is provided a lie or not. However, in the Indonesian regulation, especially in the core systems, lie detector is just a tool. It's still required kind of a justification from the judge whether this person wrong or not, with some of the evidence that become support for this kind of cases, something like that. Thank you, Pak Dr. Joko.
Okay, thank you, Professor Ford. Okay, we have 1 hour, 5 minutes for this plenary speech first. So we will close this plenary. We give applause for both speakers. Thank you very much, Professor Ford, for your joining, and Dr. Fahmid Al-Farid. We have your successful in the future research and also your working in your university. Thank you very much.
Okay, thank you.
Thank you. Bye-bye.
Bye-bye. Okay, we have finished for the plenary session first, and we will move to the second. We go to Master of Ceremony.
Thank you, Mr. Joko Haryono, PhD, for moderating the session. We will continue the second panel session that present Mr. Dr. Engineering Budi Prawara and Mr. Alexander Filonenko, PhD, that will be chaired again by Mr. Joko Haryono, PhD. To Mr. Joko Haryono, PhD, the stage is yours.
Now we move to the plenary session 2. We also have 2 speakers here. First is Dr. Budi Prawara from National Research and Innovation Agency, Republic of Indonesia. Welcome to Solo, Pak Budi. Yeah, and the second is he has already joined in the virtually, Dr. Alexander Polanenko. How are you, Dr. Sasa? You never you have no turn on your mic, Sasa? No sound? Not. We cannot hear something from you, Sasa. Okay, maybe the engineer will communicate with you to improve your sound. Before speeches, I want to introduce both speakers. First is Dr. Budi Prawara. As I mentioned, now he is chairman of research organization to Electronics and Informatics in National Research and Innovation Agency, and he obtained Doctor of Engineering from University of Ryukyu, Japan.
1, 2, 3, 4.
Oh, good, Sasa. We have clear your sound. In 1999, right? The doctor degree? 2004, so already past 20 years ago. No, before, you have not yet professor in Britain? Okay. We pray for your success.
Thank you.
Okay, Dr. Budi will talk about autonomous system in Indonesia, especially for vehicle. This is very interesting. He is regulator, also some practices, right? I mean, practice. His organization also practices this and regulate for this autonomous system. So we will waiting for his speech for today. And the second, Dr. Alexander Filonenko. Yeah, Dr. Alexander obtained his master and doctor from University of Ulsan. He is my colleague when I in Ulsan, and now he is working in Cloud Atlas. This is one company in Russia which implement AI. He is a practitioner. I mean, his doctor is to analyze and in the research area and also implementation in the real application. So from both speakers, we expect his sharing and his knowledge. I think it's very interesting. The first, maybe we have 20 minutes for speech, Dr. Budi and Dr. Alexander. 20 minutes for speech, and then 20 minutes last for question and answer. Now time is yours, Dr. Budi.
Okay, thank you, Dr. Joko. Can I stand? Yeah, Dr. Joko Haryono, Chair of ICIERI 2024, distinguished speakers and participants, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, still morning, yeah. Yeah, first I would like to thank you to the committee who invite me to give, to share our activity, especially for development of
autonomous system for electric car, and also some work on mechatronics. Yeah, my slide is shown in Zoom. Okay. Yeah, so I have 20 minutes. Please remind me if my time is over, Pak Joko. Yeah, this is my outline of my presentations. Yeah, first I would like to introduce our research organizations. Research Organization for Electronics and Informatics. This is one of research organizations in National Research and Innovations Agency. We have 12 research organizations, and RO for Electronics and Informatics has home base in Bandung. Yeah, it is around 580 kilometers from Jakarta. And yeah, you can visit our homepage here, BRIN Go ID OREI. Yeah, this is our organization structure. Under my research organizations, we have 7 research center for telecommunications, electronics, data science and informatics, AI and cyber security, Center for Computations, and yeah, related my presentations, I would like to introduce Center for Smart Mechatronics, and the new centers starting from this year, Center for Geoinformatics. Yeah, this is some brief information regarding Research Center for Smart Mechatronics. As we know, the development of mechatronics, yeah, combination of mechanical, electrical, and informatics engineering, and also control engineering now become yeah, it is also become increase in the world. And yeah, we for intelligence mechatronics, so we makes a combination from all dynamic mechanical system driven by instrument in the form of electronic control with intelligence in sensing and also information processing, decision making, and also actuator. And yeah, there are some research scopes in this center. The one is regarding the instrumentation system, secondly, autonomous system, intelligent dynamic system, and also we have also a biomechatronics. Yeah, this is briefly our research program until end of this year. Yeah, we have 2 research focus program. The first is autonomous vehicle or smart intelligent transportation system, and secondly, AI, big data, computational technology for biodiversity and satellite imagery. Yeah, actually, we have also some research activity on the disaster countermeasure technology, wireless sensing, detection system, and medical equipment, and also some related research such as precision agriculture and aquaculture. Yeah, so I would like to share you our research progress in autonomous vehicles. Yeah, the background of these research activities coming from our task to carry the research and innovation in the field of electronics and informatics, especially for mastery the key technology to produce the prototypes and autonomous system in electric vehicle technology. And by this activity, we do hope that we can increase our competency of our researchers to mastering the key technology of autonomous electric vehicles. And we do hope also we can helping the industry and developing the small medium enterprise and also the creative industry based on technological innovation and business model innovations. Yeah, this is some issues and background of our research activity on autonomous vehicle. Especially, as you know, our government has a plan to establish already established the new capital city in Kalimantan or IKN. This is a kind of smart city, and our government also has a plan to establish the intelligent transportation system based on electric vehicle, and how we can reduce the utilization of a private car. So we are thinking the implementation of autonomous vehicles or sharing car in this capital city. Yeah, as we know, we have 6 levels of driving automation. The level of number 0, it is as we know our mostly our conventional vehicle. There are no automation. The vehicle is fully controlled by the driver. And the level number 1 and until number 3, I think this is already implemented in commercial car for as we know as driver assistance, partial automation, and conditional automation, where the vehicle conducts some parts of driving without driver engagement and monitoring driving environment. BRIN, our National Research and Innovation Agency, now we do the research activity to establish the autonomous vehicle on level number 4. This is the high automations, but we still have the steering because when something wrong happen, the passenger will take over the steering. And the last level is level number 5. This is full automations. Usually there are no steering, so the vehicle can perform entire driving without human input under all conditions. This is the roadmap of our autonomous system based on electric vehicle. We are starting from, actually our research organization was established just 2 years ago on 2022. We are starting from small. So we use as individual or single passengers, low speed and low mass. And we have some research topics regarding the object detections using camera, LiDAR, and also we use also radar. And the research topic regarding the information and telecommunication system, big data, and data security for autonomous electric vehicle. As we know how the vehicle can make communications with other or another car, and environment, that we usually mention as a cellular vehicle to everything, and also vehicle sensor, computer vision, and human vehicle interaction, and also voice recognitions. Yeah, as shown in the slide on the right side, this is our prototype for single passengers. We are now going to we do some testing activity on a limited area, because this car we have a target for utilization on a limited area, not in the road. This is our work breakdown structure of autonomous electric vehicles. On last year, we have 45 research subtopics regarding this cluster, starting from the rolling platform, traction system, inverter, motor controller, charging system, onboard computer system, SLAM sensor, and also automatic steering system and autonomous control systems. For doing these programs, we are not make a limited team. So we have actually more than one team. There are 4 teams to establish some kind of the single passengers or individual electric autonomous vehicles. The number ones, we say microelectric vehicles. This is a kind of a single-seater autonomous vehicle which used on special area, and mainly the object detections using camera and 2-dimensional radar. And we also have team number 2, which developed also single sister transporter using SLAM for the moving of the vehicles. And the team number 4, they focus on how they develop some subsystem in the autonomous vehicle, like steering controller, tractions, and also brake controller. And team number 4 focus on the research on detection object using LiDAR, 2-dimensional LiDAR, and also 3-dimensional LiDAR, and also thermal camera. And we also another team which developed the multi-platform that we can use on for example, on airport, to deliver baggage from the parking area to the terminal. This is some of our research activity on individual mobility system using universal platform. And we already tried this kind of platform on indoor. We have a special test indoor. This we say UniPath, Universal Platform of Autonomous Vehicle. There are 4 modes of autonomous. The first is line followers, and also we can use trajectory planning, point-to-point destinations, and the last is human following. This is what we say, the intermediate output before we are going to the level 4 of autonomous vehicle. We have doing the activity on teleoperated driving system. I think by this technology, we can implement it on some target area like a special area. For example, which has potential hazard for chemical, nuclear, and etc. Yeah, this is the video of. You can see this is when we testing the vehicle in indoor, yeah. Sorry. Yeah. For the micro autonomous electric vehicles, now, we have some sub activity on vision sensor and localizations, robot operating system, machine learning, how they can make the mission planner, path generator, and also motion planning, and also mechanical improvement of the platform. This is the brief information regarding 2024 activity. And previously we have a problem on real-time kinetics, how we can optimize the position of the vehicle using the RTK other than single positions. And this is the comparison between location mapping using GPS single position and RTK, so that RTK improve the accuracy of GPS data. This is some activity on object detection using stereo camera, which can identify the other car on the road. And this is lane detections using Hawk transform, and also when we use other transformations, which result more smooth. This is another team which is developed the object detection using LiDAR, 360 camera, and also thermal camera, and also they also has activity on how to make the algorithm when the vehicle facing the object on the road. This is some video, how the LiDAR which integrated on our mini computer, and this is also the experiment how the braking system working when the object facing on in front of vehicles. And this is the achievement of human object detection, and also road recognition segmentation in thermal image, which is we operate on the night. Yeah, and another team developed the battery-based autonomous electric vehicle four-wheel control system. They focus on developing the local controller for steering, brake interactions, real-time monitoring module, and autonomous global controller for MGO. Yeah, this is the schematic diagram of the subsystem. Yeah, this is the a kind of I think this is the kind of transport robot of transporter, yeah, single passengers that has the some potential use on delivery of goods, indoor passengers, and also outdoor passengers, mobility for impaired person, and also indoor goods delivery. I would like to show you a short video. Son? Yeah, sorry, there are some noise. Yeah, this is this single seater transporter using SLAM, yeah, to mapping the environment, and after that we can make some program to set the starting and the end of the destinations. We can use this kind of vehicle indoor and outdoor. Okay. Yeah, and this is some other achievement on our development of especially electric vehicle with some level of autonomous. We also developed three wheel single passengers cars that we developed especially for disabled people. Yeah, this inspiring by the one of disabled a boy, yeah, in Semarang, Jawa Tengah, namely Gading. Yeah, he has limited ability, but he want to work, yeah, to obtain, yeah, to got some money by we say selling some good, yeah, by bicycle, firstly by bicycle, and after that we collaborate with PT VR to develop three-wheel passenger car for disabled people. This is the final prototype. This is already got the certifications and already commercialized. And also some collaborations with electric car industry like Wuling. They give us also single passengers, yeah, that we can use to develop the autonomous vehicles. And yeah, this is some of our other research activity on mechatronics. For example, we also has activity on developing the monitoring of growth freshwater prawn using video image processing from underwater ground. This is ASEAN EVO projects, which leads by Dr. Hanif. Yeah, also precision aquaculture to control the water quality of fresh water lobster cultivations. And this is how we also use the artificial intelligence to optimize the nutrition and water provision to increase chili plant productivity based on IoT. And this is the development of smart hydroponic farming using IoT and nanobubble technology. Yeah, the nanobubble technology is our original inventions and now already implemented on, especially on agriculture area to increase the productivity of plant. Yeah, I think if you are the coffee coffee addict, yeah. We also have some research on how we can make a good coffee by AI on a roasting machine. Yeah, so we detect the second crack of the coffee bean. Coffee experts say the second crack is produce the good quality of the bean, yeah, after roasting. And yeah, this is the intelligent gripper robot to select the fruit, yeah. And also some research on biomechatronics to, for example, to help recovery of the stroke patient, yeah. And also the assist suite for palm oil harvester. This is also now we this activity is we are going to introduce to the related industry to commercialize this kind of assist suite. And also we have research on the health sector, for development of ventilator. During the last COVID pandemic, we already developed some ventilator, emergency ventilator, and also CPAP, BPAP, and ICU, until ICU ventilator, the most highest level of the ventilator. Yeah, I think this is the last. So we also now manage the journal. Yeah, if you are interested, please you can visit our website. This is Journal of Mechatronics, Electrical Power and Vehicular Technology, already indexes on the Scopus. Yeah, I think the last is I would like to take this opportunity also to offer some collaborations with the participants. We have some research scheme and also some facilitation. For example, we have the open research infrastructure, so you can visit our website to see our infrastructure, and also research and innovation facilitations using pendanaan research and innovations, not only for research but also some scheme for example, for the certifications and also for clinical trial, expeditions, and some innovations products. Yeah. And also how we can improve our research capacity by research mobility, by visiting researcher scheme, visiting a professor, and also a degree by research, which is open not only for brain researchers, but also for external researchers. Thank you very much.
Okay, thank you, Dr. Budi. Let's applause for him. Thank you. Okay, I'm sure you have a question. However, we try to keep your question, and we move to the second presenter, Dr. Alexander. Are you there?
Yes, can you hear me well?
Okay, now your times, Sasa. Welcome.
Yeah, I have a. Can you stop the sharing the presentation? I've sent the request to start mine.
Yeah, we can hear. Now.
Yeah, I'm not able to share yet. Okay, now I can.
Okay.
Nice. I hope you can see my screen, my presentation.
We cannot see. We haven't seen.
I'm sharing my screen.
Okay. Wait. This is some trouble.
Okay.
Not yet, doctor.
And maybe now.
Okay, now it's better. Okay, Dr. Alexander, now your times.
Okay, thank you for inviting me today. Today I'll be talking about automatic image annotation, and actually I'll be talking about our industrial use case. So let me tell who I am. I got specialist degree in Russia in 2011, long time ago, and I got my PhD in electrical engineering in the Republic of Korea at University of Ulsan with our respectful Dr. Joko. And actually, right now, I'm pursuing another master's degree at AI Talent Hub in Russia, just to keep up with the innovations. And actually, I also teach at this university, at ITMO. And I have 3 journal publications and 43 conference publications. And I was working at Beeline as a software engineer, and then ABBYY or ABBY as senior computer vision engineer, where I was working with text detection and optical character recognition. And right now I'm leading 2 groups at Cloud Atlas as lead computer vision deep learning engineer, where we work on smart city project, which is video analytics, like human detection, face detection recognition, and cars, license plates detection recognition. And why I want to talk about image annotation. Like in our company, we have access to multiple cameras, really a lot of cameras, from which we can get some raw images, which we can use to train our models. But the problem is that for many AI-based businesses, that these raw unlabeled data cannot be annotated by people in short time to get good results. Usually we have millions of images and we have like 10 annotators, and they spend months to get the results. So we want to speed up the process. And also another problem, unlike in academia, public data sets are not available for commercial use. There are really nice data sets, for example, for human detection and for face recognition, but we just cannot use these data sets by license. So our solution is automatic labeling of these data sets, and we're focusing on like face detection, face recognition, and human detection. And I'll be talking about human detection today. Why we don't want to use human annotation for at least type of companies which I work at? The first one I said, the just annotation process is so slow. And other things, I hope you know Andrei Karpaty. It is a prominent scientist in the machine learning field. And when he prepared the CIFAR-10 dataset, CIFAR-10, he wrote a blog post where he said when he annotated 400 images, he already found out he had 6% of errors. So this amount of errors when a single human annotates a lot of images is quite high, and it actually increases when you have to annotate more images. Human tends to be tired when working for hours and make more errors. And next time, when he prepared the ImageNet dataset, the famous one, and he and other experts, they were given a task of annotating just 100 classes, not the 1,001. So people were making from 5 to 15% of mistakes. So if you want to get a clean data set, you have to annotate the same image by multiple persons and then combine their results, compare their results, and make some voting to decrease the error rate drastically. So it increases the time needed to annotation, and also it increases the cost of annotation by humans. So at Cloud Atlas, we actually have annotated human faces for recognition, clusterized human faces by the actual persons, and we found out we had 1.4% errors after annotating by two people, the same image by two people. We already used the cross-validation, but still we got the problems. But if we check what we have in the deep learning field, that the best results at CIFAR-10 give us less than 0.4% errors. And Florence, for example, model at ImageNet gives us less than 1% errors. You see 1,000 classes, less than 1% errors. Experts, human experts, 100 classes give like about 5% errors. So the question at my company was, can we actually make use of auto labeling by ensembles and outperform manual labeling? And also, when human annotate images, they tend to do it in different ways. These are two examples of two data sets. One is crowd human, second is wider person, as far as I remember. And you can see in crowd human, all the limbs are within the bounding box. But when we see it wider person, bounding box covers mostly head and torso, but limbs, for example, this leg is outside the bounding box. So there is inconsistency among different data sets. And this inconsistency will lead to errors when you train the networks on different data sets, when you combine different data sets. And here are just a couple of demos how our system worked. I hope you can see. This was the first version very long time ago, about a year ago. And we could clusterize people using our library. And we combined face detection, ensemble of face detections, and ensemble of descriptor extraction algorithms. And they provided quite good results, but here we don't have any numbers how good it is, because these results are based on our open source library, which doesn't contain all the why it is not full screen. Doesn't contain all the models we use. And the second one, the second task is, let me make it better, is human detection. Here I'm using ensembles, and when we use a single model, for example, RTDeter, we get some problems. Here we detected all the people, but sometimes a single model tends to make more errors. Here we have false positive with the dog, but other things are detected quite well. Even people very far away, they are detected. And then if we use multiple models, for example, here 3 models, and we have some voting, we can get rid of false positive results, and also we can filter out some results. Here we filtered out these legs. You can say in real life it is a human, but we cannot use this information for later processing. We cannot use these legs for personal identification, for example, and we consider these kind of problems, this kind of markups as false, and here we don't have any false positives. So in our case, this is just demo. It's nothing about numbers, but let me show you what actually happened with the numbers. Okay. So, in my company, we have decided to create a library to automatically annotate images for face detection and recognition and human detection. And our ideology was that we want to make it free and open source by the code, and also we are using free and open source models in the library, which is available publicly. And we wanted it to be easily installed by using pip. Just pip install auto-annotator, and then you can use it. But there are problems. Actually, in our company, we are training some heavy models, maybe models which are better than we can find in academia, but we cannot publish them due to NDA, and we have our internal fork with internally trained models and models which we have purchased. And somehow we have just 10 stars, but 9,000 downloads. I don't know who the people who are using our library, but someone is using it. So why do we want to use ensembles? They provide better performance compared to a single model approach, for sure. Probably, as you know, ensembles, they are better than a single expert, and they have better uncertainty modeling, and they actually reduce variance by keeping the bias, so they generalize better. And in our case, how we use these ensembles, we have experts, which are neural networks, for example, human detection networks, and they provide us with prediction of bounding boxes as well as confidence scores for each bounding box. And we aggregate the bounding boxes from each expert, considering their confidence scores as weights, and then we finally build the bounded boxes. To have this aggregation, we actually use the method weighted boxes fusion from Roman Solovyov, from other Russian scientists, who proposed to weigh these boxes by their confidence, including they include Roman and his colleagues. They included this weight into the interpolation of X and Y coordinates of the bounding boxes. And actually the results are much better than non-maximum suppression algorithms, which are commonly used in the detection tasks. Here, this is the example. We have ground truth, and we have red and blue are predictions of the networks. We have 3 experts, and actually WBF approach shows much better results. If you want, you can read this paper for the details. And in our case, what kind of experts or models we have used? We have used 2 models which are publicly available, and they are free and open source, which are top 4 and top 8 on crowd-human dataset benchmark. And also we have trained our own models. First one is ResNet 101, which is not so good, but it's top 9 in the ranking on crowd-human. And we have trained DDQ Deter, which is now top 3 actually in the world. It was top 2 in the beginning of the summer, but someone beat us. And we trained this network by ourselves with different image resolutions. And actually now, we are number 3. But the best model is intern image. Unfortunately, authors haven't published their weights for the model, so we couldn't for human detection, so we couldn't use this model. So datasets which we are using to train and to test our models are crowd, human, and wider person. They are created for human detection, and for automatic annotation tests, we used CUHK CISO. This dataset was created for human re-identification, and on the right, you can see that this dataset is people annotated only that are at foreground. All the people at the background, they are not annotated. So if we train ResNet 18 on this data set, we get just 52 or 54 mean average precision. No, it's average precision at IU at 0.5. If we tested this model on crowd human and wider person tests, crowd human and wider person, they're kind of well annotated. All the people are marked. But the problem is here again that limbs are cut out from the bounding box for wider person. So this is kind of troubling data set, but still we get very kind of low results. And then if we automatically label with a single model, the best one we have, DDQ, which is top 3 right now, the average precision increases drastically on crowd human, and it increases about like 5 points for the wider person, or 16% relative percent. Or if we automatically label with the ensemble of 4 models, we have increase in both wider person and crowd human. Crowd human performance is quite similar, and wider person increases drastically, about 6 points. And if we train the same model on ResNet 18, we get even higher results, but this is the soft maximum which we could achieve with automatic annotation, but we were not able to achieve. But still, we can see that we had 2 hypotheses, that labeling with assembles is better than coarse manual labeling. Yes, it is. And labeling with ensemble is better than labeling with the single best model. Yes, actually it is. We get better generalization. And about generalization, when we had the crowd human data set, which is well actually annotated, and we trained the ResNet 18 on this data set, and we check the mean average precision on crowd human, wider person, and Cook CISO, we get quite low values on wider person, but for 2 other data sets, results are good. But if we automatically annotate, AA is automatic annotation, we have consistent increase in performance in all 3 data sets. In this case, if we use just crowd human for training. And then what if we combine manual labeling and auto annotation? First, about crowd human, I just moved the numbers from the previous slides. Yes, we know that it is better than just a manual annotation. But what if we have pretty nicely annotated dataset crowd human and add another dataset CUHK CISO with automatic annotation? Then results are not so consistent. Here we have drop in mean average precision in crowd human and wider person a little bit, but increase in Cook CISO. But then if we increase the number of the data, we combine 2 manually annotated data set and added automatic annotation, then we have increase in generalization, meaning that the network trained on these data sets perform well on all data sets in similar manner. You can see we had just 29 mean average precision, 29%. Now it can increase to 48. And if we use only automatic labeling, actually it doesn't improve quality so much. It improves quality for crowd human and Cook CISO, but in wider person, actually here we can see in the 4th line, the quality is decreased. But probably the problem is the way how the bounding boxes for ground truth are annotated for wider person. As I have shown before, the limbs are cut out for the people, so there is inconsistency in the ground truth in the test sets. And actually, before I made all the tests for ResNet 18, why we tried to tackle this problem? RT-Deter with the ResNet 18 backbone. In industry, we try to make algorithms work in real time, and we need to use small models. And automatic labeling is kind of distillation of knowledge from a set of large models to a small model. So this is our goal, but actually we have tested what happens if we automatically annotate crowd human and then train DDQ with Swin L backbone, and actually performance dropped, probably due to we still, by automatic annotation, we have some errors and inconsistency comparing to human annotators, and large model has the capacity to learn these errors by itself or to learn the noise of the ensemble. This is the final chart, but in general, if you have a lot of manually annotated data and then not annotated data, the best strategy will be to use the data sets which are manually annotated and then automatically annotate the rest of the data and combine all the data together. If you combine all the data, you actually increase here, and I think it's the case number 6, you increase the overall performance in many cases, you better generalize. And here are the visualization examples. On the left, it's Cook-Siso original annotation, and on the right, we can see the automatic annotation. We still lose this person and some people at the background, but these people are like 10 by 20 pixels. It's you cannot reliably detect probably with the best networks, these people by the best networks. This is another example. Automatic annotation finds all the people in the image. Thank you. If you want to contribute to our auto annotator or just try it out, you can scan the QR code. And this is my LinkedIn account if you want to connect and discuss some topics. How should I say? Terima kasih. I hope I pronounced well.
Okay, thank you. Give applause for Alexander, Dr. Alexander. Okay. Thank you very much, Dr. Alexander. I am still recognize this text. This is from Dr. Wahyono, right?
Right.
Yeah. Okay. Okay, we have finished 2 talks. First from Dr. Budi. Dr. Budi has presents about autonomous system, especially and in some intelligent system in National Research and Innovation Agency. So it is not only regulations; it's also practitioner. So you can ask or confirmation something from him. And the second is from Dr. Alexander. Dr. Alexander from Cloud Atlas, Russia. He speaks about auto annotation, especially for researchers. Annotation is very important to make our system is high performance and high accuracy. But problems, annotation is hard work. I mean, it takes time, and we should make expense times much. That's why auto annotation is more useful if we can make auto annotation. However, now auto annotation is have some limitations. So how we can improve this limitation, accuracy improve, and also auto annotation is also work well for this. So from both, we open the discussion. If the first session we start from the offline, now online participant or virtual participant have first opportunity. Any question or confirmation? Raise your hand or text your message if you
I have a question. May I?
You have question?
Yeah.
For Dr. Budi?
Yeah, for Dr. Budi.
Okay. We give first opportunity for him.
Dr. Budi, thank you for your presentation. Your group is doing so much research, and I'm interested in the electric vehicle you have shown with cameras and LiDAR. And actually, Dr. Joke and I, we have also experience with automatic autonomous car, where we have used LiDAR. And actually, LiDAR doesn't always have signal when there is raining. Actually, we have participated in the competition, and many teams have encountered these problems where we used images and LiDAR data, but LiDAR data just disappeared when it is raining. So do you have this kind of problem? If yes, how do you tackle this problem? When in different conditions, LiDAR doesn't return signal.
Okay, yeah, this is especially in our laboratory, we have some part of work, and Dr. Alexander, especially in LiDAR. He is very expert in LiDAR, and he has one problem. If the day is rainy, we cannot use LiDAR as well. So how we can solve this problem, Dr. Budi?
Yeah, thank you very much for your questions, Dr. Alexander. Yeah, we found also some problem actually on our research. So that's why, yeah, we use not only a LiDAR as tools for detections the object. We combine some a sensor, like a camera, stereo camera, and also we already try the thermal camera that can be used not only, especially on the night and low visions, and we are going to try also radar, but this sensor is expensive. So our team now try to improve. For example, we have also research on how we can improve the camera sensor so they can use on low visibility. I think this is the challenge, and we try to improve.
Okay, Sasha is already answered.
Yes, thank you.
Okay, thank you. The second question from from floor. First is Fauzan. Can you give the mic?
Thank you a lot, Dr. Budi and Dr. Alexander. The material was so interesting. Actually, I have some question for Dr. Budi because I'm interested in the autonomous vehicle that was being presented by Dr. Budi. Actually, when you are doing your presentation, you didn't mention how long can the autonomous vehicle. Actually, I appreciate that Brain as mashallah, they have already gone. They have developed a lot because they are now reached the first level 4 of the autonomous vehicle. So that means the driver just need just little interference. So the question is that how long can the autonomous vehicle that was being made by the Brain theme, how long can it travels for on a complete charge, and also because we know that the most famous challenges that was being faced by autonomous vehicle, especially electric vehicle generally, is that the battery needs to be developed. So I want to ask, for the Brain theme, have you implemented the regenerative braking? Because when I was going through some in our class when we are learning, so it can be maximized so that it can make the electric vehicle travels long. So this is just a little question for me. Thank you, Elisa.
Okay. First, I will confirm, Mr. Fauzan. First is about how long. It means time.
Yeah.
How long?
How long can the can the vehicle travel on a full charge?
From level 0 to level 5, right?
You mean the time for charging?
No, like kilometers. How many kilometers can it travel?
Yeah. Oh, how far? How far?
How far?
Yeah,
Okay.
And the second is about the battery. This is now, I mean, progress. You use battery.
Yeah.
What
Okay.
is it? Okay.
Yeah, thank you for your questions. So our single-seaters autonomous vehicles, I would like to inform you, the specifications. The weight of the vehicle is about 180 kilograms, and we use a lithium-ion battery, 48 volt and 41 ampere hours. The vehicles can travel on speed around 10 to 20 kilometers per hour because this is light and low mass and also low speed. So we setting this is not fast moving. And we already try the time. For using battery fully charging, it's around 2 hours and 40 minutes. I think we also thinking that this is a challenge as you mentioned. So we are thinking how when we implemented this kind of vehicle on the road, so we have some options. For example, because this is autonomous, so we can develop the system to detect the another or other car which still has the level of battery energy from the information, so the car can communicate with the other or another car to obtain the information of level of battery. When they found near by the vehicle which has a high level of battery, so they can go to the neighbor vehicles and make the charging with contact. This is I cannot explain more detail how the charging will take over, but mostly by contact charging. We have experience to develop the not using the conventional pluging, but use some special pluging. So the contacts only surface and male and female. Male and female. This is the one options. The other option is using wireless charging. We also have this kind of research, wireless charging. So when we can put some wireless charging area on the road, and we can use, for example, when the car stop during the intersections, they can waiting and charge the battery. You mentioned the regenerative braking. This is also one solution for make additional energy to the battery. I think that is my answer.
Okay, how?
Okay.
It's answer?
Yes, sir. Thank you, Dr.
Okay, thank you, Fauzan. Before we ask, give more opportunity, Dr. Alexander, I want to ask some things, especially your company is running commercial, right?
Yes.
Sell this application. Annotation is more research work than the commercial work. I mean, we try to collect data and something, and we can produce a system more accurate, more improve the accuracy and performance. But this is, research work. Your company, how to produce money from there?
Okay. There are many companies who work in video analytics, and we have to compete with them. So actually, in our company, we have an R&D department, and I'm leading 2 groups in this R&D department, and we're doing research work to beat our competitors in both quality and the inference speed. We are trying to make very small networks, neural networks, which work on par with state-of-the-art academic papers on quality. So actually, without research, we cannot compete even in industry.
Okay, good. So you want to work in perfect. I mean, you try to use all effort to compete with others, right?
Yes.
Okay. Okay. How about time? Time is over. Unfortunately, we have 1 hour more for this speech. Thank you very much for both speakers, Dr. Budi. Thank you very much, and also Dr. Alexander. Thank you very much, Alexander.
Thank you for inviting me. It was a pleasure to see you again, Dr. Joko.
Yeah, maybe next time we can invite you to Indonesia and join in person. Okay? Okay, thank you very much, Sasa. Okay, give applause for both. Okay, we already finished first and second plenary sessions. So we come back to Master of Ceremony. Thank you very much.
Okay, thank you to Mr. Joko Haryono for moderating the session. Before we proceed to the next agenda, which is lunch break, I would like to remind you that there will be an award announcement at 3 p.m. For all audiences, please enjoy the session lunch break.
Well, for the next agenda after lunch break is technical session.
Wassalamualaikum warahmatullahi wabarakatuh.